Exponential growth and decay functions. Let's set the stage. You have 100 Oreos. You can't just stay in your house, and you eat 50% of the Oreos each day. Which means in a chart-like manner here, so we'd have day and number of Oreos. So at day 0, we have 100. Day 1, you're at 50. Day 2, we are at 25. Half are gone each day. Day 3, you'd have 12.5. So what's happening each time? We are multiplying by 1/2. So if I'm interested in day n, my equation would be 100 times 1/2 to the n power. Let's do a quick check on that. So on day 3, you would have 100 times 1/2 to the third. Use your calculator. So 1/2, or 100 times 1/2 to the third. And you get 12.5. This is an example of exponential decay. What does that look like on a graph? If I start here with 100 Oreos, here's day 1. At day 1, you're at 50 Oreos. Day 2, you are at 25 Oreos. Day 3, 12.5. So I have this asymptote across here. You will always have some kind of part of Oreo left. So you have an asymptote at y equals 0. But this is an example of exponential decay. So what is exponential growth? Now let's start with 100. Oh, that would be a lot. Let's start with 10 creatures, and they double every day. So we are at day and how many creatures? So at day 0, you have 10 creatures. Day 1, you have 20 creatures. Day 2, we're at 40. Day 3, you're at 80. It's doubling every day. Day 4, 160. So if I have day n, I'm going to start with 10 creatures. I'm doubling each day, so I'm multiplying each of these by 2. Raised to the n power. Let's check that. So let's look at day 3. So it means I start with 10, 2 to the third power. So 10 times 2 to the third is 80. So at day 3, it checks. This is an example of exponential growth. What does that graph look like? I start at 10 on day 1. On day 0. Day 1, I'm at 20. Day 2, I'm at 40. Day 3, I'm at 80. So this graph does the same. Well, this is exponential growth. Instead of exponentially decaying, this one is exponentially growing. Y equals 3 to the x. I want you to think of that as the same as saying y equals 1 times 3 to the x. So that 3 means I am tripling It's a triple factor. So this is a growth function. All right, when it says 3 to the x, I want to know, we're going to put 0 here, and let's go backwards, -1, 1, and 2. So I'm going to let that exponent start at 0. So then I use my calculator. 1 times 3 to the -1 would be 1/3. 1 times 3 to the 0, 3 to the 0 is 1. 1 times 1 is 1. 1. 1 times 3 to the first, so I have 3. 1 times 3 to the second would be 9. So I go back 1 up 1/3, 0, 1, over 1 up 3, and 2, 9. I'm going to draw an asymptote across here at y equals 0, because this is really adding plus 0 to this equation. So whatever number is at the end is where my asymptote will be. Then sketch your graph. Your y-intercept, what is the y-intercept? Y-intercept is when you let x equal 0. So when x is 0, we can see that the point is right here. So my y-intercept is 0, 1. My base number is 3. My domain, I can put anything in for x, so it is all real. And my range, my smallest, it is 0 to infinity, because it will never reach 0, but it goes to infinity. Next equation, y equals 2 times 4 to the x. So my multiplier this time is 4. So we have a growth factor again of 4. My exponent is x, so I'm going to put this at 0, -1, and then go 1 and 2. So 2 times 4 to the -1 would be 2 times 1/4, which would be 1/2. 2 times 4 to the 0. Well, 4 to the 0 is 1. 2 times 1 is 2. 4 to the first is 4 times 2 is 8. 4 to the second is 16 times 2, 32. So you can see it is being multiplied, each of these, by 4. That will verify that multiplier or growth factor of 4. If I'm going to sketch this thing, I'm going to go back 1 up 1/2, 0, 2, 1, 8, and then 2, 32 is up here. Where's my asymptote at this time? It's at the same plus 0, which is at the end of this. So this is the same thing as saying plus 0. So y equals 0 will be my horizontal asymptote. And then sketch your graph, making sure that it stays above that 0. What is my y-intercept? It's when I let x equal 0, so I can see that's at 0, 2. My base is 4, or the multiplier. My domain on these will be always all real. And my range on this one is 0 to infinity. All right, so now we have y equals 3 times 1/2 to the x. So this is 1/2, meaning this will be a decay. So my base number is 1/2, so we should see things go away. We're going to add a plus 0 to this. My exponent is x, so let's put 0 here, -1, +1, and 2. Use your calculator. 3 times 1/2 to the -1 would be 3 times 2, so this gives me 6. 3 times 1/2 to the 0, anything to the 0 is 1. 3 times 1 is 3. 1. 3 times 1/2 would be 3 halves, or 1.5. So you can see these are being multiplied by 1/2. So a half of 1.5 would be 0.75. All right, so back 1, up 6. 1, 2, 3, 4, 5, 6. 0, 3. 1 and 1.5. And 2 and 0.75. Again, the plus 0 at the end means my horizontal asymptote is at 0. So we can see this is exponential decay. My domain will be all real. My range will be 0 to infinity. Oops, make that better. And my y-intercept is 0, 3. Next one, 5 times 1/3 to the x. So my base number this time is 1/3, and the 1/3 will be of decay. Again, plus 0, so that gives me my horizontal asymptote will be at 0. So let's draw that in right now. And that's from whatever number is here at the end. My chart again, I'm going to put 0 here, go below it 1, and above it 2. So now let's use the calculator. So 5 times 1/3 to the negative 1 would be 15. 5 times 1/3 to the 0. 1/3 to the 0 is 1. 5 times 1 is 5. 1, 5 times 1/3 would be 5/3 or 1 2/3. And 2, let's use a calculator. 5 times 1/3 squared. And you get 0.55. For making that a fraction, it looks like 5/9. So sketching the graph, back 1 up 15, 0, 5, 1 and 1 2/3, 2 and 5/9. My y-intercept, you can see, is 0, 5. We found that point. Domain is all real. And range will be 0 to infinity. Notice that your y-intercept each time is this number at the front. Explain how the function is a translation of 4 to the x. Notice it has the plus 1. And just as yesterday when I saw a plus 1 with the x, it meant it moved left 1. Negative of 4 to the x means it's being flipped over or reflection over the reflect x-axis. 4 to the x minus 2, nothing is with the x in the exponent, so this is just moving down 2. This one has everything going on in it, so if I have, I'm going to erase this. Let's start this one over. Let's go g of x equals 4 to the x minus 2 plus 5. I'm going to change that. So the x minus 2 moves it right 2 and up 5. Last 2. Y equals 4 to the x minus 1 plus 2. So this is moved right 1 up 2. So I'm going to start here with 1 for my x value. So the fact that it moved right 1, I'm going to start with that x there, and then I'm going to go below it and above it. So when I put in 0 for the x, 4 to the 0 minus 1 would be 4 to the negative 1, and then plus 2, 2.25. Put in 1. 1 minus 1 is 0. 4 to the 0 plus 2. So it's 1 plus 2, I get 3. 2. 2 minus 1 is 1. 4 to the first is 4. 4 plus 2 is 6. 3, 4 to the, so 3 minus 1 is 2. 4 to the second plus 2, 18. All right, so I know my asymptote this time is at 2. Zero is at 2.25. 1 is 3. 2 is 6. And 3 is 18, way up here. Sketching this graph, keeping in mind my horizontal asymptote is at 2. My y-intercept is 0 and 2.25. Base number this time is 4. Domain is negative infinity to infinity, always on these. My range this time, though, will start at 2 and go to infinity. And this is an exponential growth function because of that base number of 4. Next one is negative 2, 1/3 to the x plus 2 plus 5. So with this being plus 2, I know this is moving left 2. So I'm going to start with negative 2 in that spot because it's being moved left 2. Go below it 1 and above it. So negative 2, negative 1, and 0. The plus 5, this is my y asymptote or the horizontal asymptote. All right, so use your calculator. So do negative 2, parentheses, 1 divided by 3, raised to the negative 3 plus 2. And then plus 5. And so you are at negative 1. Negative 2, so we have negative 2, so just change that negative 3 to a negative 2. And you get 3. Negative 1. So it's negative 1 plus 2 in the exponent. And I'm at 4.3. And 0 in the exponent. And I get 4.7 or 4.8, sorry. So we graph the horizontal asymptote at 5. 2, 3, 4, 5. So go back 3, down 1. Back 2, up 3. Back 1, up 4.3. 0, 4.7. This is kind of a strange graph because of that negative 2 in front. It does strange things with it. It flips it over the x-axis. But we could still answer these questions. So 0 and 4.7. My base number this time is 1/3. Domain is all real. And you can see the range on this will be all my y's are less than 5, which will be the same as saying negative infinity. Stop at 5.